All right. We're looking at 3-2 today, solving systems of inequalities by graphing. If you guys have your colored pencils or markers at home, this would be an ideal lesson for you creative folk out there. All right. So we graphed systems of linear inequalities in chapter 2. We also graphed linear or absolute value inequalities as well. This chapter, we're looking at graphing systems of linear inequalities. Okay, so keep in mind, we're going to graph each of these, and then we're looking for the overlap of the two regions. All right, just like the solution to the system is the intersection of those two lines, the solution to a system of inequalities is the overlapping region of the two. All right. I am not a, I guess I'll kind of show you as we go through things here. So let's just start. Our blue line, we have a solid boundary line. Our y-intercept is 5, 1, 2, 3, 4, 5. And our slope is -2, down 2 over 1, 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 up 2 left 1, up 2 left 1. Bam, like butter. Okay. Question is, which way are we going to shade? Well, if you kind of remember the shortcut, y is less than this line below it. Okay. So I'm just going to kind of put an arrow over there. I don't like doing the hashtag and crisscross. I like just putting the solution on the graph. If you do like to do the hashtag, you know, and crisscross and change the colors and use your colored pencils and just make sure your solution is the darkest region on your graph. I like to just shade the solution. All right, so this next one, looking at a red line, we're going to have a dashed line. Y-intercept is -6, 1, 2, 3, 4, 5, 6. And our slope is -1/4. So we get down 1 over 4, down 1 over 4, up 1 left 4, up 1 left. Whoops, 4, not 3. All right. So in this case, again, looking at the shortcut, it's in slope-intercept form, so we can kind of use that shortcut idea. Y is greater than the red line above. Okay. So what I'm kind of looking for is above the red line and below the blue line, which is going to be that region there. Again, if you want to, I'll kind of do this quick, a little mock graph, if you will. Oh wait, that was a solid line. If you want to do like that, and then, you know, that, so I know that this region is your shaded region, you are welcome to shade like that if you want. If you want to kind of hold off on shading so you know your solution, that's a-okay as well. All right, continuing on, looking at this next one, it looks like we have two parallel lines with different y-intercepts. So we have a y-intercept of 8, slope of -4, down 4 over 1, down 4 over 1, down 4 over 1, down 4 over 1. There we go. And this one, we're looking for y's are bigger than, okay? So I'm shading above this line. If I go to the next one, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This one here, y is less than below, okay? If you notice in this situation, we have one line that we're shading above and one line we're shading below, but they are in fact parallel lines. So when I look at this, there is actually no overlapping region between these two because we're shading the blue line this way and we're shading the red line that way. Since there is no overlap, we would say this system has no solution. So again, just be mindful for those special cases as we go through things. All right, taking a peek at Mr. and Mrs. Rodriguez, or Senor Rodriguez and Senora Rodriguez. Driving across the country with their two children, they drive a max of 10 hours each day. Mr. Rodriguez wants to drive at least 4 hours a day so he doesn't have to deal with the kids, but no more than 8 hours a day because his bum is going to get tired sitting in that same seat. Mrs. Rodriguez can drive between 2 and 5 hours per day. Otherwise, we'll say, she has eye strain because she has to wear sunglasses or something. I don't know. But so she's limited to 2 and 5 hours a day. We want to write a system of equations based on these. Well, let's let Mr. Rodriguez be X and Mrs. Rodriguez be Y, and let's come up with some equations that can help us plot and graph this situation. Well, we know they're driving across the country and they have at least 10 hours a day. So the amount of time each of them drives cannot be more than 10 hours. So X plus Y is less than or equal to 10. Then continuing on, Mr. Rodriguez drives between 4 and 8. So we know that X must be between 4 and 8 hours. And then finally, Mrs. Rodriguez drives between 2 and 5. And that is my system of linear inequalities. So if I were to graph these, we have vertical lines at 4. Sorry, that line got off. 1, 2, 5, 7, 8. 4 and 8. We also have horizontal lines at 2 and 5. And then if we use our intercepts, 2, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So we have our system of inequalities graphed. We have 2 horizontal, 2 verticals. Now we're looking for the solution to the system of inequalities. All right. So if you notice, we're between the blues. We're between the greens, and then we just need to figure out which way am I going to shade on my red line. So I'm going to test 0, 0. If I plug in 0, is 0 less than or equal to 10? Yes, it is. So I'd want to shade the side with 0, 0 on it, which means I'm shading below the red line, and again, between the blues and between the greens. So that's the solution to this system. The last type of question you're going to look at is finding vertices of a boundary region. If you notice, when we have 2 lines, you did this in section 3.1. You set them equal to each other. You can use substitution, elimination, graph, or use a table to find that point of intersection. We're going to be doing the same thing, but just keep in mind that we have boundary lines, okay? So, for instance, on this one, if I wanted to solve, say, trying to think which one should I do. Let's do the first and last, okay? So if I want to find the point of intersection of those 2 lines, what I actually have in essence is this. So we have y equals negative 3x minus 6. We have 11y plus 7x equals 12. So you kind of want to take your inequalities, convert them to equations, and then solve just like we did back in section 3.1. Okay. You notice this one's set up really nicely for substitution. So I'm just going to go ahead and use substitution to solve. We wind up with the negative 3x minus 6. We're going to plug in for y. We get negative 33x minus 66 plus 7x equals 12. When we solve, we get negative 26x equals, if I add 66 over here, I get 78, which means x must be negative 3. All right. We figured out our x, so the question is, how do we figure out our y? Well, I'm going to go back into one of my equations and plug it in. Negative 3 times negative 3 is 9. 9 minus 6 is positive 3. And that is the point of intersection of those two lines. I would then have to do the same thing to find the second point, because this region enclosed by these three is a triangle. So I would have to do 2y equals x minus 16. I would have to do 11y plus 7x equals 12. I would also have to do y equals negative 3x minus 6. 2y equals x minus 16. And then I would have to solve those as well. You can check out the completed notes for the worked out solution on those. Since these problems do take a long time, when you look at your assignment, you'll notice we've done probably about 17 of these problems. I'm just kidding. There's only, you know, 1 or 2 of these types of problems, since they are actually solving 3 systems separately. So, but again, you're just solving those systems like you did back in 3-1. So if you have any questions, let me know. Log into the Google Meet during class time. Use the discussion board. And again, most of the time, our answers are going to be nice integers answers. There are a couple that have fractions, but they're nice fractions. It's not going to be like, you know, 13/11 over 57 90-seconds. Okay, it'll be like 1/2, 2/3, 3/4, 1/4 kind of thing. But yeah, the assignments on the weekly planner in the Dropbox. If you have questions, like I said, let me know. Otherwise, good luck on this assignment.